Hi, my name is Haley and I'm a food science major from the class of 2019. I will be working through practice problem number 3 in chapter 3.3 in the General Chemistry Workbook. Please try the problem on your own and then we can go through the problem together afterwards. So this problem asks, what is the molarity of a solution prepared by placing 13.8 grams of potassium carbonate into a 500 milliliter volumetric flask and diluting to the mark with deionized water? In this problem, we will be working with molarity in order to find the concentration of a solution. Molarity is a way that concentration, or how much solute is in a solution, can be presented or calculated. So, molarity is equal to, sometimes written as big M, moles of the solute over liters of the solution. So we know that molarity is equal to moles over liters. However, if you look back into the problem, we aren't given either of these values. We will need to use what is given and convert it to units that we can use to calculate molarity. Instead of moles, we are given grams of the solute, and instead of liters, we are given milliliters. So the first step is that we are going to have to convert grams into moles. So we are given that there was 13.8 grams of the solute potassium carbonate, and we are going to want to convert that mass given into moles of potassium carbonate. And we can do that using the periodic table and the molar mass. We are also given the volume of the solution, which is both the solute potassium carbonate and the deionized water that was added. However, we were given that in milliliters. So we are going to want to convert the 500 milliliters into liters of the solution. And we can do that using our metric prefixes. So once we convert these into the units that are needed for the equation, we can easily plug them into the molarity equation and solve for the answer. So the first thing I'm going to do is convert grams into moles. And to do this, I need to find the molar mass of K2CO3. To find the molar mass, I need to add the masses of each individual atom, potassium, carbon, and oxygen, that are on the periodic table. So if you look at the periodic table, potassium has a molar mass of 39.0983 grams per mole. Carbon has a molar mass of 12.011 grams per mole. And oxygen has a molar mass of 15.9994 grams per mole. So if you look at our compound here, you can tell that we have 2 potassium atoms. So I'm going to multiply the molar mass by 2 to get 78.1966. Carbon, we only have 1 in the formula, so I'm just going to multiply that by 1. So that is 12.011. And for oxygen, we have 3 in the formula. So multiply that by 3 and get 47.9982. I'm going to add these all up to find the combined molecular mass of potassium carbonate, and this is equal to 138.21 grams per mole. I am now going to use this molar mass that we just calculated as a conversion factor to get between grams to moles. So I can write this molecular mass as two different ways. I can write it as 138.21 grams over 1 mole, or I could write it as 1 mole over 138.21 grams. So we were initially given 13.8 grams. And in order to get to moles, I need to cancel out grams. So I am going to use this second conversion factor. That way I'm dividing by the molar mass and we can cancel out grams to get and be left in moles. As you can see, if I write it that way, this grams and this grams can cancel out. And now we are just left in moles of potassium carbonate. So this is equal to 0.0998 moles of K2CO3. So now we have calculated moles. The next step is convert to liters, and then we can plug back in. So now the last step is to convert milliliters to liters. We can do this by using a conversion factor that you need to memorize, which is 1 liter is equal to 1,000 milliliters. This also can be written in two different ways. We could have 1 liter over 1,000 milliliters, or 1,000 milliliters over 1 liter. So we initially started out with 500 milliliters. So we want to cancel out milliliters in order to get to liters. So we want to divide by 1,000 milliliters. So I'll have 1,000 milliliters over 1 liter. That way our milliliters cancel out, and we are left with 0.5 liters of solution. So now we have both moles and liters of the solution that we can just plug back in to the molarity equation and solve for what we were trying to find in the first place, the molarity of a solution prepared by placing potassium carbonate in deionized water. So we know molarity, big M, is equal to moles of the solute, which we calculated as 0.0998 moles, divided by liters of the solution. So we calculated that as 0.5 liters of solution. If you plug that into your calculator, you should get 0.1996 molarity. So this is what we were trying to solve, and we calculated molarity of the solution. Thanks for listening, and hope this helped solving this problem from the chemistry workbook.